Hi everyone, welcome to our tutorial video again. Today, we'll show you how our Python program solves a real-world problem using the divide and conquer approach. The task is to divide the state X into the region based on the specific factors to make the governance easier. So let's dive in.
Let us first discuss the problem. As the new president of state X, you need to divide the state into regions to make governance more efficient. Your advisor suggests splitting state X into 8 regions based on the 5 key factors. The first factor is demographics, or the age of the oldest individual in the population. The second factor is the geography, or the percentage of land area versus water. The third factor is the socioeconomics, or the employment rate. The fourth one is the behavioral qualities, or the tribe's population percentage. And lastly, we have number of potential governors, or the number of leaders available to govern the regions. Our goal is to create a Python program that calculates the number of regions state X should be divided into, based on these inputs.
Now let's take a look at the code we've written to solve this problem. First, we import the necessary libraries or math for rounding up the result and time to measure the program's execution time. So Python import math and import time. Next, we define a function called calculate_regions. This function takes 5 inputs, which is the D, G, S, B, and V. It ensures that the values for D, G, S, and B are between 0 and 100. If not, it raises an error. So, define a function named calculate_regions that takes 5 arguments. So, D, G, S, B, and V. Inside the function, check if V, G, S, and B are all between 0 and 100. If any of these values are outside this range, raise a value error with the message D, G, S, B must be between 0 and 100. Then, the program calculates the number of regions using this formula. So, regions is equals to D divided by 100 plus G divided by 100 plus S divided by 100 plus B divided by 100 and divided by 4 times V. So this formula averages the normalized values of D, G, S, and B. Then multiplies the result by the number of potential governors, which is the V. And finally, it rounds up the result to the nearest whole number using math.ceil. So Python regions is equals to D divided by 100 plus G divided by 100 plus S divided by 100 plus B divided by 100 divided by 4 times V, and then return math.ceil or regions.
In the main function, we prompt the user to input values for D, G, S, B, and V. Then we call the calculate regions function to compute the number of regions. We also measure the program's execution time using the time module and display the results along with the execution time.
I'll go first. So let's say we have the following inputs. For demographics, we have 100. For geography, we have 75. For socioeconomics, we have 50. And for behavioral qualities, we have 40. And the number of potential governors is 10. Let's run the program with these values. You can see the program calculates that state X should be divided into 7 regions based on these inputs.
Next, I will use this set of inputs. So demographics or D is 71. Geography or G is 59. Socioeconomics or S is 99. Behavioral qualities or B is 33. And the number of potential governors or V is 18. So now let's see what the program outputs. So here is the output. So the program suggests dividing state X into 12 regions for these inputs.
In the third test run, we have inputs of demographic, which we have 68, geography, 56, socioeconomics, 82, behavioral qualities, 62, then number of potential governors, 13. Upon running, we have the number of regions of 9.
Now, I'll use this set of inputs. Demographics, 94, Geography, 75, Socioeconomics, 99, Behavioral Qualities, 90, and number of potential governors, 8. The program suggests dividing state X into 8 regions based on these inputs.
Finally, I'll use the last set of inputs. So, in demographics, I'll put 93, geography, 56, in socioeconomics, 29, in behavioral qualities is 60. So, in number of potential governors is 4. So, let's run the program. So, the program output is the number of region is equals to 3. So, the execution time is 0.00262. For these inputs, the program calculates that the state X should be divided into 3 regions.
And that's it. Our program successfully calculates the number of regions state X should be divided into. Based on the given factors, this is a great example of how divide and conquer can be applied to real-world problems. Thank you for watching our tutorial video. We hope this demonstration was clear and informative. See you next time!